So welcome everyone to my talk. This is about continuous reliability testing, so software testing, most exciting topic in the world. I'm making up for it by having the loudest outfit at the crypto conference, apparently. So I'm Max. I'm the Director of Applied Research at Antithesis. So Antithesis is a software testing company. That's why I'm talking about software testing. What we do is deterministic simulation testing. We call this autonomous testing. I'll make a little reference to that later, but mostly this talk is kind of a manifesto for a certain way of development and a way of life around producing software. And it's going to have three parts. So the first part, I'm going to make the sort of high-level theoretical case for why this approach is really important. Part two, I'm going to talk about my experience being in charge of our client at our company and how we changed the way that we were building that using these techniques. And then part three, I'm going to give you some best practices, pitfalls to avoid, and then take some questions. So let's do it. Okay, so I don't know if you guys can really see this, but a large portion of this talk is going to be about, it's a pretty simple graph, so I'll talk you through it. But a large portion of this talk is going to be about convincing you that this relationship or something like it exists. So what does the chart say? For those who can't read the faint colors here, the x-axis is time to bug. So what I mean by this is the time from when you check in code that makes a bug occur, makes it possible for a bug to occur, to when you actually find that bug. So as you go right along that axis, that is increasing. And then the y-axis is just any measure of badness that you might care about in software development. So, you know, cost, frustration, overall wasted time, like people wanting to quit, just really almost any way that you can think about the problems that having to go and fix bugs and that debugging causes, that goes up the longer it takes you to find a bug. And there's some very important implications to this. And if you, like me, do not really like debugging, if you don't like having people win your bug bounties because there's bugs out there for your software, then you should want to move to continuous reliability testing. So, okay, why does this relationship exist? You know, maybe people believe me that it's there, but what are the factors causing it? So, first thing is you don't want to be doing it. Almost nobody wakes up and says, I want to go debug an issue today. And really nobody wakes up and says, I want to go debug a week-old issue, a month-old issue, a year-old issue. Like, you've moved on. So if you go, you write a feature, you check in some code, like you're very excited to be working about that, and it's what you are thinking about, it's what you woke up to do, it's what you want to be focused on. But when a bug report comes in, this is a very different phenomenon, right? There's some sort of urgent problem that's occurring, and all of a sudden there's now a task that takes you away from your actual priorities and what you want to do that's being inserted at the top of your priority queue. Not fun. And you know, if you find a bug very fast, maybe you've still got some ambient interest in the problem that you were working on. You know, I don't know about you guys, but for me, no feature's ever really fully finished. Like, there's always a bit still kicking around there. And maybe you're still a bit interested. But as time goes on, it's really not what you want. And in fact, maybe you're not even the person who was involved in this to begin with, so it's a task that, you know, you've got to go understand somebody else's area and somebody else's code that's being inserted into your work. So that's phenomenon number one. Almost never do you want to do the thing. That's a big reason that people hate it. Number two, you don't have context about the thing anymore. Related problem, right? So when you're working on something, you have a lot of state in your head about the system that you're working on, the invariants that you need to worry about, subtleties, etc. If you catch a bug immediately, you're still going to have that state, but it decays very quickly, and as time goes on, you're going to need to go and rehydrate that state. And again, if you wrote the problem, it's one thing. If the bug is from somebody else's code, it's worse. If that person isn't around anymore, it's even worse. If everybody who really understands this code is gone, it's very bad. So the longer it takes to find a bug, in general, the worse this context problem is going to be. And after a certain point, it's kind of like nobody really has context or remembers this anymore, and you're just at this like flatline level. So, all right, next one. This one's a little bit more subtle. So if you find a bug right away, and you are able to keep producing that bug and new instances of that bug at that rate, right? So I'm making an assumption that you're not just getting lucky finding a bug right away, but actually you're finding it right away because you can find it quickly. Then you actually have a lot of knowledge about what might be wrong because you have source control. you know what code was checked in recently. And if you're running tests continuously, and those tests are relatively stable, and all of a sudden you start to see a bug every 5 minutes in your testing, well, you have a pretty good sense that that bug probably has not been there for an hour, hasn't been there for a day or a week or longer, right? In contrast, let's say you start to see a bug and you're seeing that bug once a month. Well, actually, now the span of possible code in your code base that could have introduced this issue is much larger, and so the search space has grown. And the reason that this is super linear here is like, hopefully your company is growing and your velocity is increasing, and so over time, the amount of code that's going to potentially need to be worried about is increasing. And it's actually even worse than I just said, because if you're looking for data points to try to qualify what potential code might need to be worried about, well, it's going to take you longer to get to that second data point at all. So if you're finding it every 5 minutes, right away you know the bug was very recently introduced. On the other hand, if you just see the bug once, right, you know almost nothing, right? You know the bug is there, right? That's kind of all you know. Like, it could have been there from day one, could have been there as long as the relevant code is affected. You could have just introduced it. Like, you really don't know. And then, let's say you now wait 1 month and you see your second manifestation of this bug. So now you know it's pretty rare, and maybe there's a good chance it hasn't been there for many years, but it's hard to say. And so you're going to accumulate data to help you drive this conclusion much more slowly. And if this bug really matters, like that degree of rarity of bug, in practice, like it's not helping you at all anymore that you're collecting this natural data. And so you're just kind of like stuck trying to reason from first principles and work your way backwards through logging. So you've lost all of the value of being able to contract the search space. So that's pretty bad. Another reason you want to try to find this stuff pretty quickly. So last effect here that I'm going to mention is the scope of what you actually have to do is also bigger. The longer that you have a bug in your system, the more code is going to come to depend on faulty assumptions or need to be unwound in some way. It's just going to be much more tricky to actually resolve the issue even after you've successfully debugged and identified it. Or at least the probability that there's a lot of stuff that you have to do is increasing. So the expected work is going up. Okay, so better to find a bug quickly than slowly. Fine. What about this? So this is also debugging. It's very easy, obvious debugging if you look at this. Like, I bet everyone can just stare at this and immediately. It's impossible not to know what the problem is. But okay, fine. Let's say that like the comment here is like actually like lots of code. You can't see the things on the screen at the same time. Still, this is a very, very powerful experience thanks to the magic of static analysis built into your editor. Because as the moment that you write this, or with a very tiny delay, you immediately know that you have a problem, right? And you know that this code that you just wrote is implicated in the problem. And like, this happens to me all the time, right? And like, I find these little red lines beautiful, right? They're not. You could imagine that something like this is like stressful, right? It's telling you that you did something wrong. Like, we're a software testing company. Like, we tell our customers that they have bugs all the time, and it's like people tend to like break out in hives, right? Like, they don't like this. It's the beginning of their debugging odyssey, right? But like this, like, it's nice because now I can just like stop, right, and fix the problem. And all the effects that I just mentioned are not there, right? Like, I'm already working on this. This just is one of the steps in working on the thing. Like, it's not kicking me out of what I was trying to do. Number two, like, I have plenty of context. It's all right there. There's no cost to rehydrating that. What was the next one? It's information about when the bug was introduced, right? Like, obviously this problem was just introduced right here. It tells me right on the line. And like, you might be saying, fine, what if actually the problem is some kind of like deeper thing where this should be allowable, right? And there's some prior thing in the code that's causing this error right now. Well, that's totally possible. And it brings us right back to the other piece of the paradigm I was talking about. So if that's the case, then your static analysis tool has caught the problem a bit slower, and it's worse. You've now got to go and rehydrate your state. You've got to go figure out why things are being done in that way, what the problem is, why it's preventing you from doing what you want. And last one here, obviously there's no new code that depends on the code on line 405 because I caught the thing immediately. Like, that problem just never had a chance to exist. So I think this is amazing. It's a much, much, much better way of doing things. So the question is there a way to have this same effect for things that cannot be statically found? for bugs, reliability problems, other sorts of issues that require actual testing? And I think the answer is yes. Continuous reliability testing is the term for this approach that tries to surface that stuff immediately. And I want to talk to you guys a little bit, right, I always forget that I have this slide here. So like testing is velocity, like, you know, the ultimate cost of producing software, usually not just the cost of writing the thing to begin with, like it's dominated by the cost of maintaining the software. And a huge amount of that is just loss due to all of the effects that I've been talking about. And it degrades the morale of teams. It's not a good situation. So how do we get to this point, right? What's the approach that can get us there? Well, the life-changing magic of continuous reliability testing. And like, you know, look at, this is not the most amazing slide in the world, but, you know, I asked ChatGPT to make me a little, you know, Marie Kondo happy person. Like, you know, look at how happy he is. There's money falling from the sky. There's like code on the back of his monitor. Like, it's amazing. On the left, I don't know, this is from our product. It's just a representation of like what it looks like to not have any bugs. Kind of a difficult abstraction to visualize. But
I think he's just looking so happy because he can't see any of the code.
he doesn't need to. It'll tell him if there's a problem. So, all right, so I used to be in charge of our client. And, you know, our client does a bunch of very bizarre, sophisticated stuff. I won't really go into the details right now, but it started out as research code. And it was research code that kind of anybody in the company could commit to. It was an experiment, like fun times, not fun times to turn into something that's actually going to work well and be maintainable. And so I became responsible for that thing when we started to have a big push to turn it into like a real product that was going to be reliable, and you know, we decided we were going to go for it. So at first, we took a traditional approach to this. We're a software testing company, but due to architectural reasons and the immaturity of the product at the time, we couldn't really use our software to test our software. So instead, we wrote a bunch of unit tests. We would try to integrate the stuff ourselves. We'd have some specific integration tests. Like, it worked okay. But by the time we added the fourth highly complicated subsystem, and we're deep in trying to evaluate the Cartesian product of complicated interactions between weird subtleties, like, we decided this is enough. We need to figure out some way to get this approach into this product. And so we then spent a bunch of time building a highly integrated mini version of our whole product into the thing so that we could have essentially continuous testing with it. And this was like the dream of continuous testing. Like, the thing is written in TypeScript, and so it's very fast to compile. And we had what we call a watch running, where it compiles immediately anytime anybody saves the file, so fast that if you then Alt-Tab over to your tab, where you've got the thing running, and refresh it, like, it's already done in 99% of the cases. So what this meant is we really had effectively continuous testing, very, very easy for people to run the thing. So, okay, we started to build the thing, got the basic version working, and immediately it was very good at finding bugs in the test engine itself. I think typical experience of building a sophisticated test. It's like the test engine just like falls apart. It's very good at finding these weird, annoying subtleties in itself. So we had to work through all those problems. Okay, next step. Starts to find all sorts of like genuine, but you might kind of argue spurious problems, right? Not very interesting bugs. Like, okay, if you write a 300, a length 300 JavaScript sparse array, it's not going to do the right thing in this exotic situation. Like, who cares? But I care because it's going to spam up my test, and I need to get rid of that thing. And so there's this big slog at the beginning to work through those issues. And finally, we get through those, and then we start to find real bugs. And those bugs are occurring like very fast in the test. It's exciting. We're definitely finding stuff we missed. Like, feels like this investment is starting to pay off. And over time, as we work through this big backlog, and this whole process probably took us like 3 or 4 weeks. And we work through the backlog, and finally we get to we can run the thing for a while, and it can't find any issues. And at this point, like, we've now entered this like Zen zone that this guy is in. Like, we know, by and large, we don't really have any bugs. There might be some very rare exotic issues that if you run the thing for like a day, it'll find. But mostly, excuse me, mostly we're in this green zone. And what's nice about that is now, all of a sudden, like, we can write code fearlessly. Right, we don't need to worry about every bit of reasoning that we might ever have to do. We still need to think through architectural implications. Are we backing ourselves into corners, et cetera? But does it work? Well, we have a very powerful way of just checking that. We can add people to the team easily and not worry that they're just going to create a disaster. Code reviews, the pressure is off a little bit. We need to think about certain issues, but we don't need to reason from first principles about how this interacts with every single bit of code that we've ever written before. And like, let me tell you, like, the reason that I continue to work where I do and believe that this company is going to take over the world is that I got to experience this like moment of what this felt like. Because honestly, it feels like a superpower. Knowing that if you catch a problem, that if you introduce a problem, it's going to be caught almost immediately. It's going to be very obvious what it was, and the cost to unwind it is going to be almost nothing. I don't know. I felt like it's like a cheat code kind of, and like that's what I think you should want to get to. And if you can get past that first upfront investment, then the promise is you can live in this world where it's very obvious if a new problem is introduced, and it's very obvious right away what the issue is. So that was my experience with it. I want to talk about a couple of best practices, and then I'll open up the floor for questions. So things that we found are very important. First of all, live on green. I talked to you guys about these like spurious errors, the stuff we find quickly. It's very important to do something about those, because otherwise they're just going to ruin your ability to understand if something is wrong. So if there's an issue that you find very easily, it's going to like spam up your results, and it'll be harder to find other problems. So this does not mean that you actually need to solve every bug immediately, especially if you're trying to migrate from an approach where you were not living on green before and you have lots of latent bugs to one where you are. Then you've got a lot of work to do. And that's okay. You need some way to suppress those issues so that they don't show up in the results. And best practice for that, make sure you have some way to know that the issue is still happening. If it suddenly stops happening, that's important information. But you need to either fix the issue or find a way to suppress it. Number two, this is where the continuous part comes in. This is really important. Test it fast, test it hard. Like, you want to get results as quickly as possible. Ideally, the tests are just ambiently running continuously, and all you have to do is like save your code, thing builds, and it runs. You also want to throw a decent amount of compute at it if you can. That helps to generate the information I was talking about earlier that tells you, is this a new thing? Did I just get lucky finding this rare thing? So that's very important. Third bullet point, run good autonomous tests that can eventually do everything. So if you write a bunch of like standard unit tests and then do continuous testing, you'll be good at finding problems within specific small domains. But you're going to miss a vast number of real issues that can be caused by the interaction between different things. And your tests don't need to be very good at very quickly doing everything, but it needs to be possible for them to do anything, so that over the lifetime of you running these tests all the time, eventually you're going to hit all of those longer tail problems. Last thing, this needs to be an iterative system. You're not going to get it right on the first try. So whenever you miss a bug, you need to ask yourself, what's wrong with the tests? Why were the tests not able to find this bug? Was I not using enough compute? Were they written in such a way where this scenario is not possible or incredibly unlikely? And then go back and iterate on the tests. And if you do that, then the tests are going to become much more stronger. It's like one of these sieve concepts. And over time, you're going to get much better at just catching stuff quickly. Last slide, common mistakes. Giving up before you get to green. This is definitely a problem we've faced as a company that provides testing services to people. It's like we hand them a big sheet of bugs, and it's like, congratulations, like now you can eat your vegetables and do all of this like remedial debugging on issues that have been there for a long time. Like, people hate this. And it's true, it sucks, right? It sucked when we did it for this thing. It sucked every time we've spun up new high quality testing for anything that didn't have it from day one. An anecdote that not an anecdote, a thought experiment that somebody at my company once dreamed up is like, imagine that you have a perfect bug oracle that provides you with one bit of information. Do you have any bugs in your code base? That's it. Press a button, it runs, you get back, do I have any bugs? Like, if you take that on any existing code base, it is not going to be very valuable, at least to start with, because I think we all know what the answer to this is. But it's actually still a very powerful thing, because if you start with just a blank document, no code, and then you just run this thing all the time, then you can maintain the property that it's saying, no, I don't have any bugs. And like, you need to get from here to there. It's going to be painful. You're going to need to work through a lot of your latent issues. You're going to need to work through stuff that is annoying to work through, that doesn't seem like it really matters. But the promise at the end of that tunnel is that now, then you do have that one bit of information, and all you have to do is keep it clean. Number two, not running often enough. Like a problem that we've had, or had a lot of our customers have had, is running the tests infrequently or running different tests all of the time. So, some people will want to run like a different test every day of the week, and then you'll run the same test, on Mondays, you'll run the different test on Tuesdays, etc. This is bad. Please don't do this. Like what this means is that the minimum time that bugs that you need that test to find is going to be stretched out to a week. And so if you think back to this, like all the points I was making about why you want to catch this stuff fast, like it's creating this discretion on the order of a week, and you're going to be very sorry if you do this. The system needs to really be as continuous as possible to work. Last piece, underpowered tests. I talked about this a little bit. Like you need tests that can really explore the space of possibilities for your program. That's going to help you catch all of the long tail issues, the interactions between systems, etc. So that's it. It's kind of our manifesto for why living on green, having continuous testing is really important and the way to transform your development experience.